So in this section, we have discussed transformations of parent graphs. We have discussed translations. So horizontal translations are somewhat counterintuitive. Subtracting a number from x then moves the graph to the right. Adding values to x moves the graph to the left, like this panda. Vertical translations are intuitive, exactly what you would expect. Adding a number moves the graph upwards. Subtracting a number moves the graph downwards. Reflections are maybe opposite of what you would expect. If you make the x values negative, then you're going to rotate the graph around the y-axis. And think about the reason is because you're flipping the x values around that y-axis by making them negative. If you make all of the y's negative, so that's -1 times f of x, -1 times y, then that reflects the graph around the x-axis. It flips the graph over the x-axis because it's making all of the y's the opposite sign. We also mentioned scaling, and we discussed reflections. So reflections again here are stated, and scaling, so this is anytime you're multiplying by a number outside or inside, that's going to affect the stretching. Now remember, sine and cosine help you understand the difference between vertical and horizontal scaling, but I don't want you too worried about that in college algebra. I do kind of want you to play with those enough that you feel somewhat comfortable with what to expect though. So a big number on the outside here, so 2 times f of x is going to double that function and it will grow twice as fast. 1 over a number 1 over 2 will slow the function down and it will grow 1/2 of that speed.